Welcome back. So for this example, they want us to calculate the trig functions for the angle negative 5 pi over 4. Now I notice the denominator is 4, and we got a pi over 4 hanging out with us. So that's going to lead me to believe that the reference angle is pi over 4. So this is good news because pi over 4 is a special angle for which we know a lot of trig function values for. And all we have to do in this case is now figure out where negative 5 pi over 4 is located in the quadrants so that we can fully calculate all of the trig angles. So let's do that. Let's draw ourselves a quick picture. And remember, if we are calculating negative angles, we'll be going in reverse. This will be clockwise. So I like to do this by counting. I know if I go this way, I have negative pi over 4. And then I'll have myself negative 3 pi over 4. And then right here should be negative 5 pi over 4. So again, that's if we're reading from the x-axis clockwise. Now we just want to pay attention to where that angle is located, and that angle is located in quadrant 2. So that gives us a heads up on when we have to go back and name the signs of everything. So just kind of a little note. In quadrant 2, our trig functions that are positive would be sine and its cofunction cosecant. So we're going to want to remember that when we are calculating our trig functions. Everything else will be negative. So let's maybe we can circle those to help us out, to remind ourselves that these have to be positive and the rest will be negative. Okay. Now, the good news about the trig functions, what we're looking at, our reference angle, is the distance from the angle to the x-axis. So that will leave us with a reference angle that is pi over 4. So I don't know, a lot of times they talk about reference angles. If t is negative 5 pi over 4, sometimes they use like a hat or a bar. The reference angle will be pi over 4. So really all we have to do is calculate the sine, cosine, tangent, and so on of the angle pi over 4, and then just pay attention to what signs they're supposed to be. Now, good news for us is that pi over 4 is a special angle. I'm going to move back into the screen. Remembering that pi over 4 is that 45, 45, 90 triangle. And those sides of the triangle, each of the legs we can say is a 1, and the hypotenuse is the square root of 2. So using our same story about relating the sides of the triangle to the trig functions and the angles, we'll have this down. So let's start off with sine of pi over 4. And remember sine, opposite over hypotenuse. So in our case, the opposite, both of them are pi over 4, so it doesn't really matter where we go. The opposite would be 1, and the hypotenuse would be square root of 2. If you prefer to rationalize, that is fine, depending on the directions again. Always pay attention to those. I can multiply both numerator and denominator by square root of 2 over square root of 2. And I will get another alternative version, square root of 2 over 2. So either one would be correct, but it depends on what they're asking for. Now, kind of keep in mind, remember that we were supposed to calculate the sine of 5 pi over 4, or negative 5 pi over 4. And based on what we know, they have the same values, but remember, we have to pay attention to the signs of the quadrants. So we're safe in this case because the sign is positive. So kind of a quick note to ourselves. I'll just write myself a positive. It is the same thing. So what would be negative? Let's look at cosine of the negative 5 pi over 4. And so remember, cosine is negative. So what you can do for yourself is remind yourself right away that you'll have a negative sign. And then now you could go straight to calculating the trig function of the reference angle. So that's cosine of pi over 4. And if we remember, keep carrying that negative sign over. Cosine is defined as adjacent over hypotenuse. And in this particular special triangle, you'll notice that if you are adjacent to pi over 4, you're a 1. And hypotenuse is square root of 2 again. Don't forget the sign. So that's one version of the answer. And again, if you prefer to rationalize, or if the direction specified, you would have square root of 2 over 2. But do not forget that you need to have a negative sign. Almost there. We're going to take tangent of negative 5 pi over 4. And reminding ourselves, we can relate it to the reference angle, but we remember that in quadrant 2, tangent is negative. So it's the same idea. Tangent of negative 5 pi over 4 is the same thing as the opposite of tangent of pi over 4. And so all we're doing is carrying that negative sign over. And tangent is defined as opposite over adjacent. And according to our particular angle, if I'm looking at pi over 4, I'm looking at this one. And they won't matter because it's the same sides. But opposite would be 1, as well as adjacent. It's also 1, but do not forget that you have negative. So if we want to simplify this just a little bit, the tangent of negative 5 pi over 4 is negative 1. Now, we're almost there. We can use the same sort of idea for the cofunctions, cosecant, secant, and cotangent. I'm going to move over just a little bit, help us out. And just reminding ourselves that we have reciprocal identities. So if we're looking at the cosecant of negative 5 pi over 4, that is going to be the same as the cosecant of pi over 4. Let me mark that a little nicer for you. And remember, cosecant, we are in quadrant 2, so cosecant is positive. So what we are doing for ourselves is taking, what do we have? Hypotenuse over opposite. Or the reciprocal of whatever we calculated for the sine. So in this case, I'll be looking at the 1 over square root of 2. And if I'm going to write the reciprocal, that will be square root of 2 over 1, or just square root of 2. And reminding ourselves that we have a positive angle, or positive calculation, excuse me. So similarly, we're going to look at the secant of negative 5 pi over 4. Reminding ourselves that secant is negative in quadrant 2, so we have that's going to be the opposite. But then we can use our reference angle, pi over 4, to help us out with the calculation. And so secant and cosine are related. We will take the reciprocal. Don't forget to carry along your negative sign. But instead of adjacent over hypotenuse, it will be hypotenuse over adjacent. Now I'm writing notes along the way, but eventually as you go through these, you don't always have to write all of these out. You can view whatever you calculated for cosine and you could take the reciprocal. So I'm looking at this particular -1 over radical 2. And then I notice, okay, it's almost the same. Don't forget, we need to account for the sign because we're in quadrant 2. So that will leave us with square root of 2 over 1. And again, because we have 1 in the denominator, we should just have negative square root of 2. See if I can squeeze that in there just a little bit more. I'm going to rewrite that a little nicer for y'all. Here we go. So negative square root of 2. Whoops. Got to get you in the viewing window. There we go. So I'll circle that. Okay, so we're almost there. We would like to calculate the cotangent of -5 pi over 4. Now you're getting the hang of this now. We're going to pay attention to the fact that we are in quadrant 2. So that means cotangent is negative in quadrant 2. And now we can straight take the reference angle. Be careful, it's cotangent. So we have cotangent of pi over 4. Now remembering for ourselves, I'll just carry along that negative sign. Using reciprocal ideas, cotangent and tangent are related. All we have to do is take the flip side. So I'm using the idea that if tangent is opposite over adjacent, cotangent is adjacent over opposite. And if we look at this a little bit further, I'm looking at, well, we just have ourselves a -1 over 1. That's the same thing. If you take the reciprocal, we will have -1. So I'll finish that off. And we now have calculated the trig functions of all 6 angles, or all 6 trig functions of -5 pi over 4, using the reference angle and the location it's in to help us with calculating these angles. I hope this helps. I'll see you in the next example.